This is Twit.
On Tuesday, I hosted MacBreak Weekly while Leo was gone, and I talked about how my kids had bought themselves this sort of Tesla coil type thing on Amazon, and how I was really afraid that they were going to burn the entire house down.
That sounds safe.
Yeah, it's not safe. So Steve Gibson, host of Security Now, always concerned with my safety, he emailed me immediately recommending a more innovative and much safer STEM gift for the holidays. It's called the Turing Tumble. And after watching the video of the creator explaining why he created it, I immediately ordered one and then emailed him to come talk to us about it on the show. Welcome, Paul Boswell, professor at the University of Minnesota and creator of the Turing Tumble. Welcome to the show.
Thanks a lot.
Hey, Paul.
So first,
coil sounds really cool, by the way.
It is cool. Like I wish they had made it. Like since then, people have also sent me like instructions on how their own kids have made a Tesla coil. So that's the next step. Actually, the next step is waiting for this to get here, and I don't even know if it got shipped last night. So I don't even know if I'm going to be able to wait for Christmas to give it to them. Tell everybody what it is, the Turing Tumble.
Yeah, so it's actually a mechanical computer powered by marbles, and it's a game. So you have a series of puzzles, and each puzzle has something that you have to make a machine to complete. So at first it's really simple. You try to put parts on the board to make a pattern of balls at the bottom. So like red, blue, red, blue, red, blue. But as it goes, it gets more and more challenging. And pretty soon you're learning binary and you're making a counter. And then you learn how to do addition and subtraction. It literally is a mechanical computer, a marble-powered computer. If it was big enough, it could do anything a regular computer can do. But even at this size, it can do an awful lot of stuff. So as you work through the puzzles, you learn how computers work at their most basic level. You learn how switches connected together in clever ways can do really cool stuff, really smart things.
And so talk a little bit about why you created this toy. I know you have kids, and what made you decide to make something like this?
Yeah, well, we have computers everywhere around us now. They're in our pockets. They're even in our microwaves and dishwashers and everywhere. But there's very little that teaches how computers work. And I really like the new push into teaching kids coding, but I think it would be great if we could also teach them how computers work. So I started working on this a few years ago, just kind of on the side. And I made it, I prototyped it, and then I brought it to work one day and everybody's like, this is so cool, you got to do something with this. So my wife and I put together a Kickstarter, and we were hoping to raise like $48,000 to pay for injection molds, and ended up raising $400,000. And so since then we manufactured it, and it's been great.
I love this. And you're talking about all these products right now that are really getting kids familiar with the ideas of coding. A toy that I've been testing out is the Kano Harry Potter wand coding kit, and I have an 8-year-old and a 5-year-old daughter, 2 daughters, and and they love it. And I don't think that they understand, and I imagine it would be the same with this, is that to them it's a toy that allows them to do really neat things, but it's the concepts that they're learning in the process, even if they might be a little impatient throughout the process, because sometimes they're like, I just wanted to do the thing I wanted to do. It's like, well, you got to go through the steps first in order to get there. So how do you successfully bridge children from the concepts that they're learning using this into applying that to something broader, computer science as a whole? Yeah.
So one of the things I like is that a lot of coding toys teach sequencing. You put commands in a certain order, and you can run them, and then you can see, did it work or not, right? And I think that troubleshooting is really important. You have a problem, and how do you go about debugging that problem? And that's the same with Turing Tumble. Is you put the parts on the board in a certain way, you start the machine running, and if it's not set up correctly, it won't produce the right output. So then you have to figure out, well, where did I go wrong? And you have to figure out strategies, and you also have to figure out not just sequencing, but sort of a big part of programming is coming up with the algorithms and the ideas of how you're going to write code to solve a problem. And that is really what Turing Tumble focuses on a lot. If a puzzle will say, make a machine that can detect if the right number is less than the left number. And you have to think, well, geez, how can that do that? It's marbles and plastic parts, right? But you think about it a while and you think, well, maybe if I did this, I could get it to work. And you try it and it gets really close. And then you fix a couple problems and you're there.
So what age would you recommend this for? I mean, I know a lot in the video, the kids are a little bit younger than mine. I have 13-year-olds and a 15-year-old, but you said that, that, and it looked interesting to me as an adult. So what age would you recommend this for?
Yeah. So I think 8 and up works the best. We've taught some classes at our kids' elementary school with it, and ages third grade and up is great. That works perfectly. And it's so I'd say 3rd grade and up is pretty good. They already know how to read, and they it just works well. And then certainly there's no age limit. It's kind of interesting. We found that kids and adults, there's not a whole lot of difference in how fast they can go through the puzzles. They start easy enough, certainly, that an 8-year-old can get quite a ways through, but by the end they get challenging, even for a professional software developer. They get pretty tough.
That is so cool. And then how much time would you say, and I realize this probably varies sharply between players, but to understand the pieces well enough to be able to create their own things. Like it's one thing to kind of like tackle the puzzles and be like, hey, I solved that. It's another thing to have an idea and be like, I know how all of these components operate so that I can have this be the outcome.
Yeah, that's a good question. So it starts off just teaching one part. So it starts off with teaching how to use this little green part here. And so you do a series of 5 puzzles, and after you kind of get the hang of this part, it unlocks another part. And this one's called the crossover. And once you do another 5 puzzles with this, it unlocks another part. And as you go, you build up sort of these tricks. And every puzzle, you kind of learn a new trick or a new concept. And I guess by the end, you've built up quite a few ideas and how to build things, and then you can make your own stuff.
I love it.
It's sort of like learning. I mean, it is that is the process of learning to code. If you went to a boot camp or something, it's like just the basic hello world and moving on from there.
Yeah. Yep.
And so how did I wonder how the manga came in. I mean, that's brilliant. Like, it's another thing that kids love. Like, right. Did you hire an artist to do that? How did that come into play?
So I used to be a professor at the University of Minnesota, and I had a research group there. And one of my students was in my office, and she was showing me some work she did, and her desktop wallpaper had some artwork on it. And I said, "Oh, that's cool. Where did you get that?" And she said, "Oh, I drew it." And I was like, "Wow, that's really good." And so I was starting to work on this, and I said, I'd really like a story to go with this. I think it'd be great if you kind of unlock more of the story as you work through the puzzles. And she was like, "Yeah, that'd be great." She does a lot of artwork, but she'd never published anything before. And so this was a new experience for her, and she nailed it. Oh my goodness. She did a great job.
What an amazing opportunity for her too. Like, now she has her art as part of the foundation of this awesome toy. I'm sure that you prototyped different ideas around this when you were thinking about it, and I don't know if it's easy to explain that, but how did this evolve? Like, from the very beginning, were you thinking that the board would be a lot smaller or a lot larger, or where did that come from?
Yeah, it kind of evolved. I knew what the general parts would need to be to make it a computer, to make it actually Turing complete. I started with 3D printing parts, and the first ones didn't work at all. And then just kept kind of making, small iterations until I finally had a 3D printed version that worked. And then I knew that, that wasn't going to be something that could be injection molded, because there's a surprising number of requirements for injection molding. It's not as easy as you'd think. So I started learning about how to do that and changing them so that they could be injection molded. And then I had the part CNC milled, which means rather than adding plastic, it actually takes a chunk of plastic and cuts it away. So when you do that, you can have it made out of the materials that it'll be in the final form, and you can get it really, really precise. And so I had the parts made, and it it worked for that one copy, but just making one set by CNC milling was like, I don't know, $1,500 or something. So it certainly couldn't be done on any sort of scale.
Right.
Well, this is amazing. And you were voted the most popular STEM toy to give for the holidays this year from the Smithsonian, which
that was cool.
Great. Like they had all the age, like 3 to whatever that, and then you were overall the best gift. So I'm so glad this is getting the attention that you deserve. You said you're no longer a professor. So is this your full-time work now?
Yeah. This came out of nowhere.
That is amazing. Wow, congratulations.
So do
I did not see myself doing this at this point in my life. That's for sure. No.
And then is there, what's next? Do you have anything that you're working on now or just getting this
out? So this takes a surprising amount of time. But I'm working on something else. I think something that could teach electronics in a more tangible way. I'm working on some parts for that, and I think it'll be really cool. I'm excited about it. It's going to be a little while, though, probably at least a year, but it'll be pretty neat.
Yeah, well, I noticed in the video you have, I think that your kids are playing with snap circuits, which was something that all my kids love.
Oh yeah, we've got snap circuits at home. My kids love those too.
Yeah, but then but then they easily grow out of them pretty quickly. So it's
they're really great. The problem is you can't see the electricity, you can't really feel it. You connect the parts together and you can tell if it works because a light turns on. But something that's a little more tangible is what I'm working on now. I think it could be cool.
Awesome. Paul, thank you so much for taking the time to join us.
Thank you.
Paul Boswell is the creator of the Turing Tumble, which is available to order now at turingtumble.com. And it's $69, we should say that. And there's discounts if you're going to use it. If you're an educator, you can email them and find out about discounts. Thank you so much.
Thank you.
Thank you so much, Paul. Best of luck.